Welcome everyone. In this video we will solve the trigonometric equation tangent of 3x equals 1 for the domain of x between 0 and 2 pi. Okay? And this might sound like or seem like an easy question to you, but in fact if you're not very careful you might do some mistakes. So first, to demonstrate this point, let me solve this question using the wrong way. And let's see what happens. So I will just draw a coordinate system to guide us. I will have x. Hold on a second. That's not x. So we have x and y. And I will say, well, where does tangent of 3x equal 1? It means that tangent is 1. So the value inside should be here, which is pi over 4. Because cosine and sine equals each other. That means x and y are the same. The angle could be pi over 4, or it could come all the way like this, so it will be 5 pi over 4, okay? Now then I'm going to say cool, which means that, so I'm just using the fact that tangent theta equals 1, that means, so for our theta, what is the theta? It is 3x, well it should equal pi over 4, so x is equal to pi over 12, or we can say 3x is equal to 5 pi over 4. So x is 5 pi over 12. And you might say these are the results. And you wouldn't be wrong to say that these are solutions. But the problem arises when you say that these are the only solutions in the domain. However, we asked you to find all the solutions. And in fact, these are not enough. There are other solutions. So how do we find those other solutions? Well, we simply find them by remembering that this pi over 4, in a sense, represents a family of solutions. So I'm trying to say, so this is the mistake, let's say. And now comes the correct way. Correct way. We want to say that 3x is equal to pi over 4 plus 2 pi n, when n is an element of the integers. Because if you have this point and if you revolve around this 2 pi, you will end up at the same point, okay? So now if we solve for x, we get that it is equal to pi over 12 plus 2 over 3 pi n, okay? And now from this we can get pi over 12 as a solution. We already had that. But now giving 1 to n, we will have 2 over 3 pi, so it is 12, 8 over 12, add that with, add that with 1 over 12, so 9 over 12, so 3 over 4, is that it? 3 over 4 pi. Would that work? Let me think. So you put it inside, you get 9 over 4 pi, it is, yeah, it works, 2 pi plus pi over 4, so it is a solution, cool. And can we have anything else? Well, let's try. If I were to put 2 for n, I would have pi over 12 plus 4 over 3 pi. So 12, 16, that is 17. So that is 17. There is not enough space. Let me write it below. It is 17 over 12 pi. It is less than 2 pi. And if you were to give 3 this time, it would exceed the domain. So that's why we stop. And now we consider the other family of solutions, that is 3x is equal to 5 pi over 4 plus 2 pi n. That means x is equal to 5 pi over 12 plus 2 over 3 pi n, which gives 5 pi over 12 as an answer. We plug in 1 to n, so we have 5 over 12 plus, let's see, what is it? It is 8 over 12, so 13 over 12 pi. And now if I were to substitute 2 for n, I would have 5 over 12 plus 4 over 3, that is multiplied by 4, so 12, 16, 21 over 12 pi. And if you substitute 3 now for n, that exceeds the domain. So in reality we have 3 solutions that satisfy the given equation in the given domain. Those solutions are pi over 12, 3 pi over 4, 17 pi over 12, 5 pi over 12, 13 pi over 12, and 21 pi over 12. Anyways, I hope this video was helpful. If you have any questions, please write them in the comment section. I hope to see you in another video. Until then, take care.